So those are the key things with functional anatomy that I want you to know about. Now, if you take just a look at the structural features of the human kidney, I think you know this already. This is just a basic diagram. I want you just to remember that our kidneys have a cortex. That's the outer portion of the kidneys. And the medulla, which is the inner portion of the kidneys in here. So cortex and medulla. And if you actually took a kidney slice out and looked at it under a microscope, you can easily distinguish between the cortex and the medulla. There's a so-called corticomedullary junction right along the kidney to where it separates the cortex from the medulla. Then we hear this indentation, just like a kidney bean, that's called the hilus. That is where the renal artery comes in with all of the blood from the heart, and then the renal vein comes right back out. And here is the ureter. Of course, the pelvis is the initial part of the ureter where the urinary fluid goes all the way down to the bladder. So our urinary fluid actually begins to collect in these so-called pyramids, and these are the collecting ducts that tend to drain into these pyramids. And they collect into what's called a minor calyx, which then goes into a major calyx, and then finally the pelvis, which then drains the urinary fluid all the way down to the bladder. Okay? So that's the basic structure of the gross anatomy of the kidney. That's what I would expect you to be able to write about the gross anatomy of the kidney. Now, what's not shown on here is we do have lymphatics in the kidney system, and also sympathetic nerves do come in here to innervate the kidney as well. And that all comes through the hilus. Now, if you take a look at the kidney and some of the structural features when you get inside of the kidney, two things I want you to be able to know, and I think you probably know this already. One is the blood flow of the kidney. From the renal artery to the renal vein, just be able to list those structures, those blood vessels. What happens is basically we have the renal artery coming in, and that branches off into what is called the interlobar arteries, going into different sections of the kidney. Then the interlobar arteries coalesce into what's called this arcuate artery right here, which goes all along the corticomedullary junction that I just mentioned. So up here is the cortex of the kidney, and down here is the medulla of the kidney. And this arcuate artery runs all the way along the corticomedullary junction. Now, from the arcuate artery branches off these interlobular arteries that go all the way up into the surface of the kidney. So renal artery, interlobar arteries, interlobular, arcuate arteries, and then the interlobular arteries. And then we have the microcirculation of the kidney, which is what I want you to know most important of all. Okay, this will branch off from these interlobular arteries, branches off into the afferent arteriole, the glomerular capillaries, the efferent arteriole, and then, not shown too well here, are the so-called peritubular capillaries. So I'll go over this again and again and again, but just jot down in there, know the microcirculation of the kidney, be able to distinguish why that is unique in microcirculation terms as what you've learned in cardiovascular physiology. Okay, now down here in the medulla we have the vasa recta. The vasa recta is the medullary blood flow. Okay, so this cortical blood flow is all up here. The medullary blood flow has these hairpin loops of capillary beds, basically, and arterioles that dip all the way down into the medulla, carrying blood, the oxygen and nutrients that the cells in the medulla need, and then it comes back up into the cortex. Okay. So we'll go over this again when we talk about some of the functions of the medulla. Now, on the nephron right here, again, I want you to be able to list the basic nephron segments from the renal corpuscle to the intermedullary collecting duct. Now, I mentioned earlier that we have superficial nephrons and juxtamedullary nephrons. This one right here would be a superficial nephron, and this one right here is a juxtamedullary nephron. Okay, let me go through the juxtamedullary nephron, let you know what you need to remember here. Here is your renal corpuscle. Right here would be the capillaries where filtration occurs. We have a branching off from here is the proximal tubule. PT, actually should be a PCT, called a proximal convoluted tubule. It's actually quite long. If you dissect a kidney and actually pull out this proximal convoluted tubule, it's actually quite windy or convoluted, so you can stretch it out to be quite long. So a lot of transport characteristics occur here. Then it begins to go down into from the cortex to the outer medulla. This dashed line right here represents the cortex of the kidney. Then we have the medulla of the kidney, which can be divided into what's called an outer medulla and then an inner medulla. Okay, it's just deeper down. That's what it is. So we go from the Bowman space right here, proximal convoluted tubule, proximal straight tubule, and then the morphology of the nephron begins to change. We go from a thick cell in the proximal tubule to a thin cell as we go down deeper into the medulla. DTL stands for descending thin limb. So this nephron, or this loop of Henle, descends into the medulla, and the cells are quite thin. We can come all the way down to what's called the papilla, or the papillary tip of the kidney, the inner part, the deepest part of the medulla. And then it has a hairpin-like structure coming back up, going up into the cortex of the kidney. So here's a descending thin limb. This is an ascending thin limb. Thin limbs. Okay, so the structure, the morphology of the cells changes. Okay. Then we come up into as you get right here in the junction of the outer medulla and the inner medulla, the morphology again changes from thin to thick, and this is the thick ascending limb, thick ascending limb as we're coming up the outer medulla into the cortex. Okay. Notice right here that this portion of the thick ascending limb comes right by its glomerulus and the afferent and efferent arteriole. I'll mention this again, but that's your juxtaglomerular apparatus. So we come to the thick ascending limb. We go off into this DT, or it should be DCT, a distal convoluted tubule. Distal convoluted tubule. And then this branches into, from some other nephrons, into the collecting duct.